All right, class. Today we're going to start Chapter 8, and we're switching gears a little bit, okay? We're going to go on to Chapter 8. Chapter 8 deals with equations in two variables. So by quick way of review, the solution to one variable problems, okay, that's basically everything we've done so far. If there's one variable, we isolate the variable by inverse operations, and when we get done, we get an answer that is really a number. Now, that number could be a fraction, that number could be a decimal, but when we get done, okay, and we find an answer, we solve those equations, we have numbers. Example, if I said 3x equals 12, well, after we isolated the variable by inverse operation, what would you and I say that x equals? Yeah, we would say that x equals 4. Well, now, when we start to delve into Chapter 8, we're going to find solutions to two variable equations, all right? And so we're going to see most of those times, we're going to use x and y, but we're going to see then that answers to two variable equations are pairs of numbers. Pairs of numbers. Now, example, okay? Let's say I said x plus y equals 3. Can you think of a pair of numbers? Yes. Okay, and we get something like this, 1 and 2. Now remember, back in Math Past, when we had something like this, we called it an ordered pair. Okay, my first entry in my ordered pair is my x value, and the second entry in my ordered pair is a y value. So we plug them in, 1 plus 2 equals 3. Okay, so when we have pairs of variables, we have pairs of solutions, pairs of numbers as our solution. Now, the first thing that they want us to do is to go through and decide if Mrs. Burton's smartboard's doing its thing. Okay, first thing they want us to decide if my ordered pair is a solution of the given equation. Well, did you notice they're not always x and y? They give us two letters, and they do go in A, B, C, or alphabetical order. So here's my equation, and they want to know, is 7, 0 a solution? Well, whatever my first number is, that's going to be filled in for A, and then we're going to substitute 0 in for B. So my ordered pair is in A, B, C order, no matter what variable letters they give me. So let's check. Is 7, 0 a solution for 3a minus 5b equals 21? So we've got to fill in and substitute and evaluate. So we've got 3 times a, well, a is 7, minus 5 times b, b is 0, equals 21. So if we do the math, 3 times 21, 5 times 0 is 0. Hey, does 21 equal 21? Yes, we got a true statement. So we would say, therefore, that the ordered pair, 7, 0, yes, it is a solution. So you're just going to basically plug in the numbers and say yes or no. Yes, it is a solution, or no, it's not. Okay, now let's try our second ordered pair. Let's see if our second ordered pair is a solution. Again, my -2 is in the first slot, so it's going to be substituted in for A, and -3 is the second slot of my ordered pair, and so it's going to get plugged in for B. So we've got 3 times -2 minus 5 times b, well, b is -3, equals 21. Okay, let's do the math and see what happens. What's 3 times -2? We've got -6. Oh, -5 times -3 is +15, equals 21. Well, what's -6 plus 15? Yeah, you're right. That's going to be what? 9. Does 9 equal 21? Don't think so. 9 does not equal 21. So our second ordered pair, -2, -3, we would say no, is not a solution. All right, everybody try number 2 in your notes. Let's try number 2 in your notes. I'll go ahead and do the first one up here while you work independently. So we've got 3 times 0 minus 2 times 3 equals 6. Remember, the first entry is going to be my m. The second is my n. So let's do the math. 0 minus 6 equals 6. Does negative 6 equal 6? All right. So hopefully you plugged in your numbers. And what are we going to say for the ordered pair? We have to say, no, it is not a solution. Ooh, fractions, Mrs. Burton, for real? Yeah, let's plug in my fractions and see what happens. Okay, we've got 3m. Remember, m is the first, okay, minus 2n, negative 1/2, equals 6. So what's going to happen? Well, hopefully you realize the 3's are going to cancel, and we've got 5. And over here, the 2's would cancel. A negative times a negative is a positive 1 equals 6. Does 6 equal 6? Sure does. So for the second ordered pair, we would say yes. So basically, we're just plugging in our values for our ordered pair and seeing if we get a true statement or a false statement. Now, that's the first thing they're going to ask us to do as we start working with two variables. The second thing they're going to do is they're going to say, hey, I want you to solve each equation if x and y are whole numbers. Well, first thing we got to remember, what in the world are whole numbers? Yeah, if you look up above my board, it says whole numbers include the natural numbers and 0. Okay, so natural numbers plus 0. Natural numbers, I'm going to put the number sign, and 0. So I have a question for you. Is a fraction a whole number? No, it's not. Okay, is a decimal a whole number? No, it's not. Okay, is a negative number a whole number? No, it's not. So they want all our answers to be whole numbers. Now, here we go. What to do when? This is a two-step process. Okay, the first thing we have to do, okay, to figure out, to find all the answers, okay, that are whole numbers. The directions may also say they want whole number solutions. Well, the first thing I need to do is I need to solve the equation for y in terms of x. Well, that just means I need to get y alone. Isolate the variable by inverse operations. So if I need to get y alone, who do I need to move first? Yeah, we need to get rid of that 3x. My inverse operation, we're going to subtract 3x from both sides. And so that cancels. Now, we need to get rid of that 2 in front of y. How do we do that? Well, we have to divide everything by 2. So final answer is y equals 8 divided by 2 is 4 minus 3/2 x. So that's step number 1. We have to solve the equation for y in terms of x. Now, step number 2, we're going to use an input-output chart. Okay, we're going to replace our x's with successive whole numbers, okay, and find the corresponding value of y. So, if my x's are my whole numbers here, what's the first whole number? Yeah, 0. So we're going to plug in 0. So we're going to plug in a 0 for x. So if I do that, we're going to get 4 minus, well, 3/2 times 0 is 0, so we get 4. So guess what? Is 0 a whole number? Yes. Is 4 a whole number? Yes. So this ordered pair is a solution for that equation. Okay, what's my next whole number I need to try? We need to try a 1. So if I go up here and I plug in a 1 for x, well, we're going to get 4 minus 3/2, because 3/2 times 1 is 3/2. Ooh, we're going to have to subtract, but do you realize we're going to get a fraction for our answer? Yeah, we need to have a common denominator, so this 4 is going to have to become 8 over 2. And so 8/2 minus 3/2 is 5/2, and we just said, hey, a fraction is not a real number, so we're going to reject that answer because it's not a whole number solution. Okay, let's try the next whole number. What's the next whole number? Well, the next whole number is 2. So let's plug that in and see what happens. I'm going to make this a 2 up here. So we've got 4 minus. Did you realize your 2's are going to cancel? And so we've got 3. What's 4 minus 3? 1. Hey, is 2 a whole number? It is. Is my 1 a whole number? Yes, so we just found another whole number solution. Now, what's my next whole number? 3. Let's go ahead and plug it in and see what happens with our math. So this is going to be multiplied by 3 over 1. So we're going to have 4 minus 9 halves. Oh, once again, I've got subtracting fractions, so I need a common denominator. This is going to become 8 halves, and I get negative 1 half. Hey, my answer is a fraction, so we're going to reject it. Okay, so we're going to find out that for this equation, I only have 2 whole number solutions. Now, here's always the big question. How do you know when to stop your input-output chart? Well, you're going to keep going with numbers in your input-output chart. Number 1, whether you could get y equals 0. Okay, you can stop there, or when you start getting negative numbers. If we start getting negative numbers, we stop. And remember, we always reject fractions. Okay, fractions and negative numbers, okay, because they are not whole numbers. So that's the idea. So let's try another one together. So go ahead and write down this equation in your notes. Here we go. Okay, so let's look at number 1. Copy down number 1 in your notes. Okay, so it says solve each equation if x and y are whole numbers. Okay, again, your book directions may say find whole number solutions. Same idea. So what's the first step? What do we have to do first? Yes, we have to get y alone. For me to get y alone, who do I need to move to the other side? Yeah, we got to move this 5x over. So we're going to end up with y equals 7 minus 5x. Okay, again, there's nothing in front of here. That means it's understood to be positive. The inverse or the opposite of positive 5x is negative 5x. All right, so there's my equation. And now I need to work on my input-output chart. Remember, we've got to start with whole numbers and keep going until we get to one of those couple of scenarios to stop. What's my lowest whole number? 0. So if I plug in a 0 up here, okay, we're going to end up with 7 minus 0, which means it's 7. Okay, everybody understand what I did? And again, both of those are whole numbers, so it is a whole number solution. What's my next whole number? Well, let's plug in a 1. What happens? If I plug in a 1, we've got 7 minus 5 times 1, which is 5, so my answer is 2. Both of those are whole numbers, so that is a whole number solution. Okay, let's plug in 2. If we plug in 2, well, we're going to get 7 minus 10. Well, what's 7 minus 10? Ooh, that's negative 3. Is negative 3 a whole number solution? No. So since we got a negative number, we can stop when we get that negative number. And so that means I have 2 solutions. We've got 0, 7 as my first whole number solution, and 1, 2. Okay, so the first time we stopped because we got a negative number, because we got 0. Second time we stopped because we got a negative number. So let's look at number 2. First thing I need to do is get y alone. Remember, step number 1, solve for y in terms of x. So if I get y alone, who do I need to get rid of first? Yeah, that negative 2. That 2 is going to subtract from both sides. So now I have 3xy equals 9. Okay, we still don't have y alone. Who do I need to get rid of? 3x. We're going to divide both sides by 3x. So we've got y equals, whoop, it's a number thing and a letter thing. What's 9 divided by 3? Everybody says 3 over x. Can't do anything with x. So that's my equation, serving y in terms of x. Okay, so now here's my input-output chart. Here we go. So we've got to plug in a 0. Hey, if I plug in a 0 there, what's 3 over 0? Ooh, that's undefined. Okay, so that's not a solution because that's not a whole number. Let's plug in a 1. That's my next whole number. What's 3 over 1? Well, that's going to be 3. Those are whole number solutions. Let's plug in a 2. Well, if I plug in a 2, we've got 3 over 2. Ooh, is 3/2 a whole number? Nope, going to have to reject that one. Let's plug in a 3. All right, if I plug in a 3, we're going to get 3 over 3. Well, 3 over 3 is 1. That's a whole number. Let's plug in a 4 and see what happens. Well, if I plug in a 4, we've got, what, 3 over 4. Well, that's a fraction. We're going to have to reject that one. How about if I plug in a 5? Okay, if I plug in a 5, what do we get? 3/5. Okay, going to reject that one. Do you realize we can stop now? Because we're going to get smaller and smaller fractions. All right? Okay, so how many solutions do I have? Okay, I have two whole number solutions. Okay, and my whole number solutions would be 1, 3, and the second one is 3, 1. All right? Okay, good job. All right, let's go ahead and look at our next slide. Let's try one more as we're getting through here. All right, let's look at this one, okay? Solve each equation if x and y are whole numbers. So once again, we're looking for whole number solutions. So what's the first step? We got to solve for y. All right, so the first thing we need to do is we need to subtract x from both sides. And now we've got xy equals 4 minus x. Is y alone yet? Well, not yet. How do we get rid of this x? Divide both sides by x. So we've got y equals 4 minus x over x. Okay? Now, that's in simplest form. So now that we've got our equation, now we can go ahead and we can do our input-output chart. So here we go. We've got x and y. Remember, we're plugging in whole numbers for x. So we're going to start with the lowest whole number, which is 0. So I'm going to write them beside each other. So we've got 4 minus 0 divided by 0. Well, that's undefined. Okay, remember the 0 in the denominator is undefined. Not going to work. Okay, let's go ahead and try the next one. We're going to try a 1. So we've got 4 minus 1 over 1. Well, what's that give us? Yeah, that gives us 3. Both of those are whole numbers, so that's a solution. Let's go ahead and try 2. Well, if we try 2, we've got 4 minus 2 over 2. Well, is that going to work? Yeah, we got 2 over 2, which is 1. So both of those are whole numbers. Let's try 3 and see what happens. If I try 3, what do we have? 4 minus 3 over 3. What's that going to give me? Ooh, 1/3. That's a fraction. We're going to have to reject those fractions. Let's try one more just to prove it. Let's try 4. We've got 4 minus 4 over 4. So what do we have? Yeah, we have 0. Ooh, 0 is a whole number. That is a whole number solution. Okay, one more, just because we can. Let's try 5. What happens? We've got 5 minus 4 over 5. And now we're going to end up with what? 1/5. Okay, and we're going to have to reject that one. And hopefully you realize, hey, I'm just going to start getting all these fractions now. So how many whole number solutions did we have? Well, we had 1, 3. We have 2, 1. And we have 4, 0. So we had 3 whole number solutions. All right, now we've got one more problem to look at. Let's look at our story problem. So if we go to the last slide here, here's our story problem. It said Ed McDonald spent $280 for some baby pigs and some chickens. The pigs cost $40 each, and the chickens $3 each. If Ed bought more than one pig, how many chickens did he buy? Now, There are 5 steps here because we always use the 5-step plan for story problems. I really think you need to do step number 1. Okay, what are we looking for? What are we trying to find? Well, we got to find what? How many chickens? We're trying to find how many chickens. Okay, now we're trying to find how many chickens, but what did he buy? Yeah, he bought pigs and chickens. Now, step number 2 is those let statements. Now, 2 let statements because we've got 2 variables. And again, you've got to use those let statements to define your variables. Well, I'm going to let P equal pigs, and I'm going to let C equal chickens. Does that make sense to everyone? Again, you don't have to use X and Y. You can use whatever letters you want because your let statements define them. All right, so now that we've got our let statements down, I need an equation. Okay, we need an equation through there. And so let's look and see what it says. It said he spent $280. He spent $40 on each pig and $3 on each chicken. Got an idea? Yeah. So we've got 40 for each pig, 40p, plus 3c because he spent $3 on each chicken. Okay, and so it equals, how much did he spend on animals? $280. Now, here's my question. And all those problems we just did, we solved for y. Solve for y in terms of x. What do we need to solve for in this equation? Yes, good job. We've got to solve for c because we're trying to find out how many chickens. So we're going to solve for c. So we're going to end up with C equals, we're going to 280 minus 40p. We've got to subtract 40p to the other side, and then we'll have to divide by 3 to get C alone. Now, here's where the fun begins. We've got to go through and find our whole number solutions. Now, we've got to do our input-output chart. What number should we start with on our input-output chart? If you're not sure, you need to go back up there and read the last sentence. And the last sentence says, if Ed bought more than 1 pig, how many chickens did he buy? All right, so we've got X and Y. So if he bought more than 1 pig, that means we've got to start with 2. Does that make sense? Okay, here we go. So let's plug in a 2 for C. If we plug in a 2, we're going to have 280 minus 80 over 3. Well, that gives me 200 over 3. Okay, is 200 over 3, is that a whole number? Definitely not. So we reject that one. Okay, now let's try a 3. If we try a 3, we've got 280 minus 3 times 4 is 120 over 3. That gives me 160 over 3. Is 160 divisible by 3? Surely not. So we're going to reject that answer because it's a fraction. Okay, let's try 4. If we plug in a 4, we've got 280 minus 4 times 4 is 160. Ooh, 120. 120 divided by 3. Is 120 divisible by 3? Yep, that's 40. So that's one of our answers. That's one of our whole number solutions. Let's try 5. What happens if we plug in a 5? I'm going to go over here. If we plug in a 5, we've got 280 minus 200 over 3. 80 over 3. Is 80 divisible by 3? Nope. So that's 80 over 3. So we are definitely going to reject that answer. Okay. How about if we try 6? If we try 6, what happens if we got a 6? 280 minus, well, that's going to be 240 over 3. So is 40 divisible by 3? No, we got another fraction. Guess what? We have to reject. We got to try one more. Let's try 7. Why do I say we have to try 7? Because we got 280 minus 280 over 3. What's 0 divided by 3? 0. All right? So 7, 0 works. That is a whole number solution. Okay? All right. Now, do you think we should still, so our 2 answers, our 2 whole number solutions are 440 and 7, 3. All right? Now, not so sure that I might reject 7-0. Now, why would I reject that? Because it said he bought chickens. He had to buy some chickens. And so that's why I would probably reject number 7. So, tonight's homework, tedious, long and drawn out. Let's find whole number solutions.